So question 1 had 4 parts. This is part A. The instructions at the top for all 4 of them says read the information below about several lines. If there is enough information, circle enough info, draw a graph, and find the rule. If there's not enough information, tell what you would need in order to find the rule. And by rule, we also mean the equation here. So the rule or the equation. So for the first one, I'm told that a line, or line A rather, has a slope of -2 and a y-intercept that's sitting right at 4. So if I come right here to 4, here's 4, right? Y equals 4. And my slope is -2. That means from there I would go down 2 units and then to the right 1. So down 2 over 1, down 2 over 1, down 2 over 1. And at a certain point then you'd grab like a straight edge and you would connect those dots. Unfortunately, I don't have a very good straight edge, but I think I could put a piece of paper here and maybe use this. That's close enough. And then it says, what's the rule? Well, I know the 2 parameters, right? I know the slope and the y-intercept, so I can write the equation of this line in slope-intercept form because I know both my parameters. So here it is. It's y equals, first parameter is my slope. How does it move? That's -2 times x, and then my other parameter is plus b, the y-intercept, so plus 4. So y equals -2x plus 4. So part B says line B passes through, and it says it passes right through the point 2, 2. So if I go over 2, up 2, there we are. All right, passes through that point. Well, that's great. The problem is, and if I saw some of you write this on your study team test, you're like, hey, there's a lot of lines that pass through that point. Which one are you talking about, right? So unfortunately, you gave me one parameter. They all share this single point, but we have no idea what the slope of this line is. So there's not enough information here. And the additional information you need is we need a couple things. We need either the slope, that would help. Or we could also just take, or another point would be good. Or something that's equivalent to another point. But as it is, it's not enough information. So part C says, okay, line C passes through the origin. Well, that's a fancy word, but that's just the point 0, 0. So we have a point there. And what's fancy about that is that origin is actually the y-intercept as well. So we've got the y-intercept, right? We know what our parameter y-intercept is. B is 0. We have a slope that's -7. So from here, we're going to go down 7 units and then over 1. That's a very, very steep graph in the negative direction. Then up 7, and I'll go back 1. So there's 3 points. They're collinear, and if I could just take my straightish edge and kind of draw the line that goes through those, that's close enough. But so that's the equation of this line. -7 is the slope, and it goes right through the origin. And then the final one is D. It says that we've got a line that passes through the point -2, -1. So let's go ahead and put a dot there at -2 and -1. And it goes also through the point positive, x is 1, and then y is 5. So I've got 2 points there. And with those 2 points, I can take a look at the slope ratio. So for example, from this point, if I start here, I've got this, it's going up a total of 1, 2, 3, 4, 5, 6 units. And as I go across to the right to connect with the point, it goes over a total of 3 units. So that slope ratio is up 6 over 3, which is 2. Well, it turns out that's m, right? That's one of my parameters. I know the slope of this line. And in fact, if I follow that slope pattern, I'll go up 2 over 1, 1, up 2 over 1, up 2 over 1. You can see that I just so happen to land exactly at this point, right? I can just read it from the graph, 1, 2, 3. So my y-intercept, b, is 3, and my slope is 2. Now, this is a neat opportunity because I know visually that the y-intercept is 3. But one of the things that would be nice to do is to practice, hey, could I find that if I knew just, for example, this point, and I knew that I had a slope of 2. And let's do that. So if we have this equation, right, y equals mx plus b, and we're just going to pick our point, right? This point has an x value and it has a y value, and we're also going to use our slope right there. M is 2. Notice what happens when we plug this in, right? So y is 5, so I'm just going to plug in a 5 for y, and that equals my slope. My slope is 2, and then my y-intercept, x rather, is 1, and then I've got the plus b. So you can see when I do that, right, 5 equals 2 times 1. This is 5 equals 2 plus b, right? 2 times 1 is 2 plus b. And if I subtract 2 from both sides, I totally get exactly what we thought, right? So what's nice about that is I had an opportunity there to practice finding the slope, finding the y-intercept rather, if I knew a point and a slope. And you can see I verified, yeah, that totally works out and I got it. Now, of course, I'm supposed to write the equation of the line. Definitely there's enough information here. And the equation of this line is y equals, let's see, 2x and then plus 3. And if I was to draw the equation of that line, right, it's going to have to go through those points. So let me just grab this ruler and just kind of draw it, sketch that line that goes through there. So something like that. All right, that's question 1. So in question 2, we're going to go ahead and plug in that x is 3. So notice how I use the parentheses here. I write 2 times 3. That's the value of x. You can see I've just plugged that in there. So 2 times 3 and then plus 3, that's the numerator, divided by 2 times 3 and then this time minus 3. So if I simplify that, let's take a look at the numerator, right? 2 times 3 is 6 and then plus 3, which is 9. So I've got this numerator of 9. And in my denominator, I've got 2 times 3, which is 6 minus 3, which is 3. So 9 over 3 is the number 3. So I get that when x is 3, when that goes into this function spits out the number 3. So that's my output, right? If 3 goes in, 3 comes out. Let's write that down and clear the screen. So this is 3. And then for the next one, I got to be even more careful with using these parentheses. So notice how I use these again. I'm going to take x and I'm going to square it, right? So you can see that it's x that gets squared, and then I have minus 2 times x, and you can see here's a spot where x is going to go, and then finally I'm going to end by adding the number 5. So what's nice about this is you can see I've totally got this all set up, and then I'm just going to bring in my value of x. See, x is -2, and it's going to go in each of these places. And it's really critical that you see this, because a common error is to look at, this is what I see often happening. People will look at this part and they'll just say, oh, that's -2 squared. Well, that's not what that says. What this says is x gets squared. And if x is the number -2, that means all of that needs to be squared, right? So this is -2 that gets squared. Up here, if I write the opposite of 2 squared, that's equal to -4, and that's not at all what we have below here, right? Below here, we have -2 squared, which is a +4, and then minus 2 times -2, which is plus another 4, and then finally, we're going to add 5 to that. So that's 8 plus 5, which is the number 13. So this one is 13. And again, the big error there is just not using these parentheses and being very careful to realize and recognize what it is precisely that's getting squared. So for question 3, we flip the order a bit. This time, instead of saying, hey, here's an x, find the output, what we're saying here is, here's the output, right? Some value x, we don't know what it is, but it's going into this function machine and it's producing 42. What is x? What x will produce a 42? And you could sit here for a while just kind of guessing values of x, throwing them in, and just keep guessing until maybe you stumble upon it. And you can also approach this kind of algebraically. And you know what? Either way works well. I might be tempted to write 4 times the quantity of 2x minus 5 and then plus 6. And I want to know basically when that is 42, when it's equal to 42. So what I've done is I set up an equation rather that basically seeks to find the answer of when is it, what value of x will make 4 times the quantity of 2x minus 5 plus 6 equal to 42. And there's a lot of ways to tackle this. I might distribute this 4 first and rewrite this as 8x minus 20 plus 6 equals 42. And then I could rewrite that as 8x minus 14, -20, and 6 is -14, and that's 42. If I add 14 to both sides, I get that 8x is equal to 56. And then finally, if I divide both sides by 8, right, x is 56/8, which turns out to be the number 7. So x is 7. We can just write it right here. And if I plug that back into the original problem, right, I can verify that. 2 times 7 is 14. 14 minus 5 is, let's see, 14 minus 5 is 9. And then 4 times 9 is 36, 37, 38, 39, 40, 41, 42, yeah. Add 6 to it and you get exactly 42. The next question, I was kind of encouraged as I was watching you take the test. A lot of you I heard saying, hey, if we could make the thing inside of this square root 36, right, that would give us our answer of 6, because it's true, you know some arithmetic, right? The square root of 36 is the number 6. And then what I saw you doing was basically like, hey, let's just make that 36. So I could basically say, hey, what is x when 2x plus 12 is the number 36? This will give me the value of x that would make it 36. Well, subtract 12 from both sides, and we get that 2x equals 6 minus 2 is 4, and 3 minus 1 is 24. So that's 24. 3 minus 1 is 2. And then divide both sides by 2, and we get that x is 12. And we can verify that, right? When x is 12, this becomes 2 times 12 plus another 12, which is 24 plus 12, which is exactly 36. And yeah, sure enough, the square root of 36 is 6. So that value right there, when x is the number 12, that produces exactly 6 out of that function. So there's quite a few things going on here, and I just encourage you to always go back and think about what exponents are, and think about multiplication and maybe the commutative property of multiplication, and just think about how things work, and maybe even play with some numbers. You know, what's 2 times 3? What's 3 times 2? What is x to the third power? What is, you know, just think about these things. For this particular problem, I'm multiplying two things, and in fact, the things I'm multiplying involve multiplication too. And when you're multiplying things, the order doesn't really matter, right? 7 times 5 is 35, 5 times 7 is 35. That just kind of illustrates the fact that I could rewrite this as 4 times 3 times an x squared times, maybe I'm going to move the other x squared right next to that so I can see it, and then times there's a y to the first, and then there's a y to the fifth power. So when I see this, right, and they're in this order like this, right, it's still all the multiplication, but maybe I can start to see, well, you know what, 4 times 3 is 12, and in terms of my x's, I have 2 factors of x and 2 more factors of x. So that's x times x times x times x, or x to the fourth power, just using the definition of exponentiation. And then I've got y to the first power, right, a single factor of y, times 5 more factors of y, y. So that's y to the sixth power. So we've got 12, x to the fourth, y to the sixth. For b, you know, I've got a 16 over 8. I totally see a 1 right there, right? 16 is the number 2 times 8, right? And I've got an 8 in my denominator. So there's a 1 already, right? And then my denominator has x to the fourth. And look at this. I'm going to break up this x to the seventh. That's x to the fourth times x to the third power. So that's still x to the seventh in the numerator. But looking at it like it this way, right, maybe helps me see, look at this. This is a giant 1, right? Those are clearly, you know, it's the same factors over in the numerator and denominator, so it's equal to 1. So what I'm left with is 2 times x to the third power. 2x to the third. And there's other rules of exponentiation, and we'll study those rules in later chapters, but think about it kind of more, you know, what's going on here. For C, this is a huge struggle, right? If I look inside of the parentheses, right, it says 3x squared. When I look at that, what's getting squared? It's just the x, right? So that's 3 times x times x. Now, when I throw parentheses around it and I write it to the third, what's being cubed? Well, the whole thing's being cubed, and that means that I've got literally a 3x squared, and then another 3x squared, and then a final third 3x squared, right? I've got three sets of these factors, 3x squared. Well, when I multiply my 3's, right, 3 times 3 is 9, times 3 is 27. So I have the number 27, but then all these factors of x, right? Remember, this is 2 factors of x, 2 more factors of x, 2 more factors of x. That's a total of 6 factors of x, so that's x to the 6th power. And then finally on D, I like that I had that problem up on the board from several days ago where I was showing how to neutralize this negative exponent. If you look at this, if I multiply this by the giant one of b cubed, right, and b cubed, what's nice about that is b to the negative third times b to the positive third is b to the 0 power. So I've got b to the 0 power. I still have this a I didn't get rid of yet. Let's write the a down. But then up in my numerator, I have this factor of a, and I have b to the second, and I just introduced three more factors of b to the third. So if I look at this now, I do have a giant 1. It's just an a over an a, but that is 1, and I can eliminate that. But then I also have in my numerator now 2 factors of b and 3 more factors of b, so I've got a total of 5 factors of b to the 5th power, and my denominator is just b to the 0, which we know is 1, right? Anything raised to the 0 power is 1. So what we have here is just b to the 5th power. These were probably the most missed problems on the test. I think they were worth 3 points each, and a lot of people had 1 or 2 points taken away. You know, consider these, look at these deeply. It's all little details, it's all things. Just play with these and then seek out more problems like this. When you see things like this, look at them as opportunities to learn. If you find a bunch of these and you're doing them, come by and I'd be happy to check your work and see if you're understanding. But this stuff takes a bit of practice. Okay, so number 5 gives us a series of 4 equations it asks for us to solve. I'm just going to go ahead and use this distributive property first to get rid of these parentheses. So I've got a 2x plus 1 plus a 4x minus 8. Notice I did multiply both the x and the negative 2 by that factor of 4 outside, and that's going to equal 11. I'm going to combine like terms on my left-hand side. That ends up being 6 x's. And then I've got a 1 and a minus 8, which would be negative 7, and that equals 11. Finally, let's add 7 to each side. That would become 6x on the right-hand side when I add 7, and it would become 18 over on the right-hand side. And finally, 18, if I divide both sides by 6, rather, 18 divided by 6 is 3. So x is 3 for number 5. For B, let's see here. I'm going to do the same thing, use the distributive property. On the left-hand side, I'll just rewrite the 4x plus 10, and then I'll write that that is 6 times x minus 30. I'm going to, let's see, I'm going to take away 4x from both sides. And when I subtract 4x from each side, I'm left with 10 equals 2x minus 30. And then I think we're going to add 30 to each side. So 10 plus 30 is 40 equals 2x. And then finally, 20 is exactly what x is. So x is 20 for part B. For part C, these are proportions. Some of you really have this. Some of you are struggling. When I have proportions, and I don't like talking about this shortcut method, but I'm going to do it now, and we'll talk more about why this works later. But it turns out that one thing you can do is multiply both sides by 4 and then multiply both sides by 7. That's equivalent to just multiplying the diagonals here. So if I multiply these diagonals, and I pretty much messed up that problem. On the one diagonal, I have 4 times x. And on the other diagonal, I have 7 times the quantity of 2x plus 1. And here's the problem that I'm seeing a lot. We're not distributing the 7 to both the 2x and the 1. And if we did that, it would correct most of the errors I'm seeing. So this is 4x equals 14x and then plus 7. So that plus 7 is what's missing. If I take away 14 x's from both sides, it's going to become negative 10x over here, and that's equal to 7. And then finally, if I divide both sides by negative 10, I get x is negative 7/10, right? I could say 7 over negative 10, or I could just say it's the fraction negative 7/10. So for 5c, x was negative 7/10. Many of you wrote negative 0.7. And then for the last one, I think if you got C, D probably was easier, right? On D, we're just going to go ahead and do the same thing with our cross products. In the one case, we're going to get 4 times x, which is 8x. And in the other case, we'll get 3 times 8, which is 24. And if I divide both sides by 8, 24 divided by 8 is 3. So we would get that x is equal to 3 for part D. Question 6 says, I'm giving you the values of A, B, and C. Please evaluate the following expressions. So here's some expressions, and one of my biggest bits of advice here is whenever you see this, right, use parentheses to replace where the variable is. So what I'm doing here is I've got parentheses squared, right? Something's getting squared. What's getting squared? Well, it turns out negative 3 is getting squared, so I'll just put that in right there. Actually, let me color code this. So anytime I see a B, I'll use that yellow, and for C, we'll use this beautiful blue. So you can see here I've got negative 3 squared, and when I square negative 3 times negative 3 is positive 9, so I end up with 9 plus 11, which is the number 20. For B, you can see the first thing I've got here is this value of B. So I'm going to set out to use some open parentheses and then close parentheses and squared. So that's, you can see that's A minus B. But inside of here for B, I'm going to use parentheses and a 4. And then minus and parentheses, I'm going to put a negative 3 in for A. I'm trying to make sure that I catch that I'm subtracting negative 3 there. And then outside of the parentheses, I've got plus 1. And then I've got plus 5 times C. And for C, right, I'm using the number 10. Oh, I was going to be real, I forgot I was going to use these colors and come in here, and for this I can put, I'll put yellow over that. And then for this one, I'll put the negative 3 inside. So just substituting those values in. Okay, so now let's clean up the arithmetic here. Inside of my parentheses, I have 4 minus minus 3, which is 7. It's a positive 7, and 7 squared is the number 49. And then I have still plus the 1, and then plus 5 times 10, which is plus 50. 49 and 1 is 50, and 50 plus another 50 is 100. So for B, our answer is 100. Let's go down to C. On C, again, here's parentheses, and then I'm going to subtract 4 times something in parentheses, and then I'm going to add 2 times something that lives in parentheses. And I'll just substitute those in. So in the first instance there, I've got C, and C is the number 10. The next instance, I have minus 4 times A, and A is the value negative 3. And then finally plus 2B, and B is the value 4. So now just clean up the arithmetic here, right? I've got 10, and then minus 4 times negative 3 would be plus 12. That's right, negative 4 times negative positive 12. And then finally there's a plus 8, right? 2 times 4 is 8. 12 and 8, that's 20. And plus 10 is 30. You can go the other way with it too. 10 plus 12 is 22, and 22 plus 8 is still 30. So addition is also commutative. But be careful with subtraction, right? Okay, final one there. D is it is this big, I've got a numerator and denominator, and I need to evaluate the numerator and then evaluate the denominator. Then I use the division, right? So I've got in my numerator 2 times this thing for B. There's a placeholder for B, plus a placeholder for C, and then plus the number 2, and then all over a placeholder for A, and then minus 2. So what is B? B is the number 4, so we write it right there. What is C? C is the number 10, so it's going to live there. And then finally, what is A? A is unfortunately the number -3, so that'll live there. In my numerator, I have 2 times 4, which is 8, and then plus a 10, plus a 2. My denominator is -3 minus 2, which is a -5. So let's simplify that numerator. That's 18 plus 2 is positive 20 over a -5. And it turns out 20 divided by -5 is exactly -4. So part D, the answer was -4. So good effort on this question. What is scientific notation? What is not? If I had 360, I don't know, 5.2 times 10 to the third power, this is not in scientific notation, right? Even though it's got times 10 to a power, right? It's not scientific notation. Maybe I could have like, I don't know, I could have, well, for example, I could have 138. That's not in scientific notation, right? I could have 0.00015, not in scientific notation. So what are things in scientific notation? Well, 3.6 times 10 to the fourth is scientific notation. 1.72 times 10 to the -3rd is in scientific notation. The hallmark of numbers in scientific notation is they always have a leading digit that's greater than 0, but it's less than 10. It's a 0, 1, 2, 3, 4, 5, 6, 7, 8, or a 9, right? You don't have a 2-digit number in front of the decimal. And then it has some power of 10. And the way I like to think about these is, look, this A is not in scientific notation, but 3.563 it's great because it's got that leading decimal, right? The problem is 3.563 is not equal to 356.3. It's not the same number. But if I multiply by 10, right, it becomes 35.63. And if I multiply by another factor of 10, 10 times 10, it becomes 356.3. So you can see by multiplying by two factors of 10, right, I convert this number into scientific notation. So the answer is 3.563 times 10 to the second power. So let's try that with B and see how that would work. So for B, the decimal in the right place, it would look like 2.85, right? Now, multiplying by 10 would be a bad idea, because if I multiplied by 10, it'd be 28.5. If I multiplied by two factors of 10, it'd be 285. I don't want my decimal to go that way, right? To get back to the original problem, I need to divide by 10. And we have a fancy way of dividing by 10, right? Negative exponents. Turns out 10 to the negative first power would be 0.285. And then if I made it to the negative second power, it would be 0.0285. And if I make it 10 to the, this is messy looking now, 10 to the negative third power, it would be 0.00285. So that's exactly what needs to happen. I need this decimal place to move back 1, 2, 3 places to the left. So that's my answer, right? 2.85 times 10 to the negative third. Let's clean that up. It looked better. Anyways, scientific notation. Definitely, if you want more information, you could check out a couple videos on the Khan Academy and just look at, what's scientific notation, how to write numbers in it, and how to get numbers perhaps out of it. So for 8, we're asked to graph each equation and then identify both the y-intercept and the slope of the equations. Pretty nice. These are in nice, easy, readable forms right now. So for A, we can see that our slope is up 3 over 2. I'm just reading it from right there. That's the parameter M. And my y-intercept is -4. That's the parameter B. I'm reading that right there. So if I start at 1, 2, 3, 4, my y-intercept at 4, this is a little small, this graph. I would go up 3, 1, 2, 3, and then over 2 units. Then I go up 1, 2, 3, and over 2 units. And if I want, I could go the other way too. I could go down 3 and then back to the left 2. You can see that's on the same line. I could go down 3 and back to the left 2. So I'm getting a pretty clear idea of what that line looks like, and probably the best thing to do at that point is just to grab a ruler and then try to carefully sketch that line with a ruler. So that's the equation of this line. It's an infinite creature. It goes in both directions. So you might want to, tack on a arrow in each direction to show that. So let's do the same thing for B. For B, my slope is -2, and I might write it as -2 over 1, just to remind me it's down 2 units and then to the right 1. But you can see that's the parameter M, it's right there. My parameter B is also visible. This is in the nice y equals mx plus b form. So I know that my y-intercept is at 6. 1, 2, 3, 4, 5, 6. I probably should grab my glasses. I can't really see that. Let's see. And then from here, I'm going to go down 2 and back 1. No. That would be a positive slope. I want to go down 2 and then to the right 1. So down 2 and then to the right 1. There we go. That's a negative slope. Keep that up. Down 2 and to the right 1. Down 2 and to the right 1, etc., etc. And probably at that point, there's enough of those there that I can grab the ruler and try to oh, that's terrible. Draw the line that goes through there. I hope you have more luck with your ruler than I did. All right, that's it for question 8. Question 9 probably is a little anticlimactic, right? For 9, we can see that we have our two parameters are pretty visible, right? One of them being B, our y-intercept. It's clearly at the point -3. The other thing that we see, just by looking at this, we can see our change in y is 4. And we can also see our change in x is 5. And we know the slope is that ratio, right? The slope is the ratio of our change in y divided by our change in x. So if we take those two values, right, we've got a change in y of 4 and a change in x of 5. This ends up being our other parameter, right, the slope ratio. So I can write the equation of the line. It is y equals, let's see, 4 over 5, so 4/5 x, and then plus -3 or just -3. So that is the equation of the line in question 9.